So as a continuation of the older video, in RRC connected, what if we get an erroneous signal from the base station to UV? At that time, we'll have a negative acknowledgement from UV to the base station. So negative acknowledgement for the for base station, in order to process that negative acknowledgement, we should give that timer, that certain amount of timer to the base station to think what went wrong. So at that time, the UV will give the base station to time to think. That timer is DRX arc RTT timer downlink. So at that time, base station will process the negative acknowledgement, and it will think what went wrong, what is erroneous at that time. So that time is called DRX arc RTT timer downlink. And soon after that, that process, this assume that this is a complete cycle. Soon after that cycle, we'll have another timer, DRX retransmission timer. So at that time base station will give the downlink data to the um, UV. So soon after that, DRX HARC RTT timer downlink, we'll have a DRX retransmission timer downlink. So that is also a timer where the base station will give the correct downlink data to the UV. Here the events, they are listed. So event UV receives PDCCH with downlink scheduling. We'll have a DRX inactivity timer that is already covered. UV will send a negative acknowledgement in DRX HARC RTT timer downlink. After receiving downlink data, DRX retransmission timer downlink is done. So I've already explained this. It's a simple concept where UV will tell that this data is wrong, and it will give time to think, give the base station to think in terms of DRX HARC RTT timer downlink. At that time, base station will figure out what went wrong, what is erroneous in the data. After thinking that, it will provide a correct data at the time DRX retransmission timer downlink. So another on time. So this is a basic simple concept. So I have explained all these concepts one by one, but this in the real world it doesn't work like that, because if it works event by event, it will take lot of time. It will take lot of time to get the data, or in order to process it, it will take hours, or yeah, hours or days. So which is one of the biggest problems. So at that time, all these whatever the processes I have explained earlier, they will happen parallelly. So that the same things I have explained here, but how it happens parallelly, that is what I'm explaining here. So RRC connected state. So assuming that this is a DRX short cycle, so we'll get an uplink data. So sorry for inconvenience. This is up arrow. So uplink data, if it goes from UV to it will go from UV to base station, and the same thing again. If we have an erroneous signal, we'll have a DRX HARC RTD timer uplink, same period, and at the same time only we can get the PDCCH with the downlink scheduling. So we'll be having DRX inactivity timer at the same time. So DRX, after DRX hard RTT timer, where the signal is erroneous, after that we'll soon after that we'll have a DRX retransmission timer where the correct data from base station is sent to the UV. So all these process, they are happening parallelly. That is what I wanted to explain here. So the all these process which I have explained one by one, they will never happen uh, one by one. So they'll be happening parallelly. They'll be scheduled parallelly. For example, event this PDCCH with downlink scheduling assignment. At that time, DRX inactivity timer is happening. UV sends a NAC in PDCCH after receiving downlink data. So DRX HARC RTT timer downlink is also DRX HARC RTT timer is also scheduled in order to give the base station time to think what went wrong, and then UV it will receive uplink scheduling assignment. At the same time, DRX inactivity timer uplink is also scheduled. So all these processes, they are happening parallelly itself. So UV will stay awake until all its timers they expire. So this is how the UV will handle its energy efficiently without compromising latency. So these are uh, very important concepts when it comes to power and latency. Thank you.